All right, so last time we were writing some client-server stuff, right? And one thing I want to do today is look at a common client-server application, which is web browsers. Well, this was actually an interesting thing from earlier. We determined that game salad represents integers as 1024-bit numbers. Not 16 or 32 or 64-bit numbers. It's 1,000. It's a gigabit number. It's an integer in game salad. Seems like overkill. Inefficient? No, it's completely inefficient. It's horrible, but they've done it anyways. Okay, so the idea here is and what we're going to do is I'm going to start our server up.
Did you pre-order your Apple Watch yet?
They have it up for pre-order?
I think so.
Well, I hadn't heard that. Are you just assuming that's the case? It's like, did you just make that up just like right now? Or is there some sort of news story to support what you're saying? All right, so we're going to go ahead and this is our actual server we had sitting here. So we're going to have our server listening on port 1234. Oh, that's right. Last time we had it just constantly getting a connection and then closing the connection, whatever. So right now we're going to have it say waiting. As soon as the connection comes in, we're going to go ahead and say we're connected. And right now we're outputting something over this connection. I'm going to go ahead and just comment out those lines for the moment. Okay, and instead what I'm going to do is I'm going to output whatever the client sends this guy. When I start the server up, what we're going to do is we're going to connect to the server. Well, last time what we did is we used Telnet, right? Command line, telnetted to it. Several of you guys opened up a connection as well. We saw it worked. Well, now we're going to use another tool for connecting to this. We're going to use a web browser. We're going to connect to our local web server now. That doesn't speak the HTTP protocol very well. We'll talk about that. But we're going to see what a web request looks like. So we'll go ahead and get this guy started. He's listening on port 1234. I'll open up my web browser here. I'm going to tell it to go to localhost :1234. Trying to open it up. We see that we got connected right here. And it's asking, here's the HTTP 1.1 protocol it's using. So it wants to get /. Okay? Now what I'm going to do for right now is we're going to take this, well, is it a big deal if I just leave it as... Well, it's not going to kill anything right now. I'm going to go ahead and run this again. And we're going to modify our request here. So here's that first connection. And now here's that second connection where we said get index.html. It's requesting a specific web page. That makes sense? So the idea here would be is that we would now output that web page. So I'm going to go ahead and write a quick little response as a string. Let's see, well, this guy will be all right, so that's our simple little HTML document we're going to output here. And after we read in the request, we're going to go ahead and not even look at what they're requesting. Instead, we're just going to output some HTML. And we'll see what comes up on the web browser. And what are we going to output? we're going to output our response, which is, in this case, a web page. All right, and for right now, I'm going to take it out of this while loop. All right, so we're waiting. Port 1, 2, 3, 4. We get our connection, get the input stream, show us what the web browser is sending to us, what that HTTP request looks like. And that gets back to our discussion. Well, we only had a high-level discussion on what protocols are. Then we're going to output a real-life web page. Go ahead and run this. Refresh that guy. There's our web page. And there's the HTML document that we wrote. All right, now, what did we just do? We just wrote a web server. That's what a web server does. Web server takes some requests and responds with HTML. Well, HTML and JavaScript. In our case, we didn't even look at the request. We just responded with our default web page that always says hello world. So it's a minimally functional web server. But do we see how easy something, well, as technologists, we might perceive that web servers are fairly complex animals, right? Seems like there's a lot to them. We just wrote one in 5 minutes. And we could certainly expound on this a little bit. We can have a couple of different requests. So, you know, here, let's say this is hello. I can't have a dot. So that's going to be hello.html. And let's say this is index. And we'll set index equal to the same thing, but with a different word in there. We'll say homepage on that one. Okay, so we read in our request. We'll store that inside of REQ. And then we'll say if request dot equals, well, let's just say dot equals, ignore case. Hello, well, let's output the request again so we can look at what it really looks like, because we're going to have to parse it a little bit because it's speaking the HTTP protocol. So for right now, we'll just respond with our hello page. I'll run this again. We're waiting. Refresh my web page. Got a response. Okay. So we get this request. This is a line of text in the language that is the HTTP protocol. All right. So the very first command in there is the get command. This is the page that it wants to, that it's requesting. Then we have the actual page. Then we have the language that it's using, the standard of the language it's using. All right, so I could split this guy on spaces. So I can say string array parts is equal to req dot split on space. And then I know that we have 3 parts, right? I know that part at bucket 0 is going to be get, parts at bucket 1 is going to be our page, and parts at bucket 2 is going to be the protocol. Okay, so I can even say string the page. Well, let's see the let's call this the function. The function that it's calling is going to be parts at bucket 0. The page is going to be parts at bucket 1. The protocol is going to be, is that how you spell protocol? Or is it CO? That's it, yeah. Parts at bucket 2. So these are the 3 pieces of information we're getting. All right, and I'm just going to go ahead and just print out the page, which should show us, in this case, the slash index.html. That's what we were requesting up here in our URL. So we're kind of seeing what the web browser does. We inputted this into the web browser. Press enter. The web browser is contacting this host at this port. The default is port 80. And it said, excuse me, it's sending as a GET request this stuff right here. Okay? That's the slash index.html. So when we print this out, we'll see that that is what the page is, the slash index.html. So I'll refresh this, go back here, slash index.html. Make sense? Okay, so now we know what page that it's requesting. So we're going to go ahead and we're just going to ask a couple of if statements. We'll have an if else. So we'll say if the page, for right now, we'll say if the page.index of I won't try to get fancy with it because we're just going to change it in a second anyways. So if the page dot equals ignore case slash index.html or the page dot equals just slash, and I'll show you why that in a second. If either of those things are true, do I have an extra closing guy there? I need to bring my print writer up here above this if statement. If either of those things are true, we're going to output index. Else if the page dot equals ignore case slash hello.html, output println hello. Else, when you go to a web server, for instance, if I say www.google.com slash, beat on the keys a little bit, slash .html, we get a 404, that's an error type thing, right? That's a common HTTP error, page not found. All right, so we want to give ourselves a page not found error. Page not found. So that's our error response. So in the else, we'll say output.println error. All right, we'll go ahead and run this. It's waiting. We're going to request index.html, which should tell us, reply with homepage. There's our homepage. I need to restart the server since I don't have it in a loop like we did before. So, start it again. Now I'm just going to request, I'm just going to go to localhost :1234 and do nothing else. We see that the web browser itself wraps this into a GET request and actually requests slash. So we still get home page. Notice what the request is right there. That's the page it wants. That's why right here I had the, if it's either index.html or it's just slash, do this. Okay? To give you a little bit more background on how web servers typically work, for instance, the Apache web server has built into it kind of a configuration file. It's called httpd.conf, C-O-N-F. And that file, what you can do is you can put in the order of importance for the default pages. So for example, typically index.html is the page that is automatically served in the event that the request is just asking for slash. But you might also have index.htm or index.php or home.htm or home.html. Several different things depending on what the web server is, home.asp or ASPX, something like that. So in this configuration file, you can usually have a an ordered list of the default pages. So it'll show, if there's an index.html, maybe that's your first choice, and somebody just puts in the slash, it'll serve that page. If that's not there, it'll look to the second option. Maybe the second option is index.html. Maybe the third option is index.php, so on and so forth. And if none of those are there, it'll spit back with an error saying that this page doesn't exist. Start my server again. So now we'll do a slash hello.html. So now we load a different page, hello world. We'll run this again. It's not a very robust web server at this point. And we will pound on the keys a little bit. And we get our 404 page not found. Okay, so now we have a little bit more functional web server. But realistically, this web server doesn't do what it needs to do as far as a full-fledged web server goes, because we're only able to handle one request, not even at a time. We're only able to handle one request, period. Then the server shuts down. Okay, so we'd like to have this server continue to respond to requests. So we can go back to what we had before, where we threw all this inside of an infinite while loop. We can run this. Now I'll request that page. Now we'll request hello.html. Now we'll just request that. Now notice something here though. See this guy still spinning? What does that mean? It's still waiting. It doesn't think it's done. All we've done is this. We've spit out some text. And then we flushed it. What we really need to do is we need to say output.close at the end to actually shut that communication channel. The servers come in with a request, we receive the request, responded to it, then we hang up the telephone. Okay? At this point we weren't hanging up the telephone. Now we are. So now if I run this, where's Amish when we need him? Let's see, where's it show me my old ones? Here. All right, so now we have it waiting again. So we'll go ahead and load the main page. Notice this guy's no longer spinning. We'll request index.html, also no longer spinning. Hello. Made up garbage. Okay, so now this guy's no longer spinning. We start to see how web browsers communicate with their servers. They send a single HTTP formatted request. which opens up a communication channel to a server, a socket. The server then gets the request, does whatever magic it does on its end, sends back a response, cuts off the communication. That's it. Okay? Now, there's a little bit more to this than meets the eye. For instance, if we were, so let's think about how a page that has a bunch of graphics in it would look. When this server spit back our page, so let's say it was something like this. Let's just go here. We'll do this on the Hello World page. Okay, so of course, following Hello World, we'll have an image of SpongeBob that's stored in a file called spongebob.jpg. This is all part of the HTML we are sending. So I'll go in, I'll request the hello.index, hello.html page. Oh. All right, so we have hello world, but notice this guy saw that we had requested an image URL. And I'll go ahead and I copy that image URL and I'll paste it here. Notice it's looking for spongebob.jpg. Come back here. Notice what we see. What did the browser do? The browser we only pressed enter once. The browser requested hello.html. We sent that response back, hung up the phone. Then the web browser looked at that HTML, because web browsers process HTML pages. It looked at it and said, oh, I got an image I need to go get. So the web browser then reopened a connection and requested the spongebob.jpg page, file. Okay? And it was expecting that from us. What did we send them? Nothing. Probably the 404 error, okay, which was not binary data, it was textual data, so that's why it gave us the little, I don't know what kind of picture you're talking about here, dealy. Let's see if we can do view page source. So this is our HTML that we sent back. As the web browser was going through and parsing this, it noticed that we had a tag that was an image with a source. It had to then go request this document. So it automatically opened up that second connection for us without us having to do anything. So we're starting to see how web browsers are trying to communicate with the web server. So the web server has to play the same game as the web browser is playing. Kind of make sense? Okay. So that's how a basic web server kind of works. Now, realistically, what would we do? We probably wouldn't have hard-coded in web pages here. Instead, we'd have a directory that had a bunch of files in it, and when somebody came and connected to it and requested a file, we would go and look for that file in the directory. If it was there, we'd serve the file. If it wasn't there, then what would we do? We'd give them the 404 error, file not found. Okay? And we saw, go back here. So as we look through this, we see that we were able to respond to that. We did respond to this with a 404 error because we know how our code works. It then connected again looking for this. Had nothing to do with what we did, but it was looking for something called favicon.ico. If you've ever been to a web page, let's see, does Google do it? Probably. Yeah, you see this little G up there for Google? That's the favorite icon dealy flippy thingy. Okay, so if a site wants to have some personalization done to it, web browsers have a standard. This is the HTML5 standard. Actually, it was an HTML4 as well, where it automatically will look for the favicon. What was the name of it? ICO file. Okay, this is a little icon file. So we didn't have that either. So we provided it 2 404 responses because our web server is pretty limited at this point. You select one of 2 web pages that we offer. If you don't give us that one, we give you nothing. We give you 404 errors. Okay? But notice all the stuff that our web browser did for us behind the scenes. All right? Now, one thing we did here is we had our web server sitting here getting, running in an infinite loop. And we didn't do this as a multi-threaded example or anything. So what we want to do is we want to now simulate a denial of service attack on our web server. So we're going to go ahead and we're going to open up our client. So we're opening up the port 1234. We need to send a request, so we're going to actually steal the print writer code here. All right, and we're going to, so we'll create a print writer using our sockets get output stream. And we're going to put this whole thing in a while, infinite while loop. All denial of service attacks should just do it forever until the thing finally breaks. So we'll create a socket opening up a connection to localhost 1234. We will get our output stream. We're going to make a request. So we're going to make a request look like the requests that were coming in before. So we're going to do output.println get /index.html and then whatever HTTP protocol. Doesn't matter. It's just the third piece. We parse that out. The only thing we care about is this part as far as how our web server currently works. And then we'll say output.flush, and then we'll read in the response and print it to the screen. And then we're going to do that again. 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 So what does this client do? This is a single point of attack. So we have a little program that we wrote in a dozen lines total that's going to open a connection to a destination host and infinitely request index.html from that server. All right. Do we still have our server running here? Okay, we don't right now, so I want to go ahead and start the server first. Okay, server is now waiting. Now, we'll go ahead and start our client. Ruh-roh. Let's see what's happened to our server conk out. Well, it says it's waiting. So I think at some point here, it finally stopped serving pages. Operation timed out. Yeah, so we got an exception. It got bogged down. So we successfully brought down our industry standard web server. We charged $9.99. What is it? We charge $9.99 for this open source crappy web server. All right, so web servers are probably not going to be written this way because everything is running on a single thread, so it'll be difficult or be easy to bring it down. Now understand that our client here is just connecting to our local host. Does anything really keep us from trying to connect to something else? I mean, let's pick our, let's see, I think that'll take us to something real. Okay, good. So we're going to take our same program here. So now the server we're going to connect to is this. And we're going to connect on the default port 80. And we're going to get index.html. All right, so let's rock.
You seriously do
Yeah, why? I host that site.
that?
It's my Are we not able to connect? Telnet. Oh, I want to do. Oh, we're not speaking the correct kind of. I think maybe we need to do this HTTP. So notice this is an Apache web server. So let's put in. That's the request we'll send. Giving back a binary response. Oh, here's one of our Cisco routers here on campus. Well, it actually looks like our campus is blocking us from making multiple requests from the same point. So we should see multiple things. Well, no, that's just on the telnet. Why do I not see a single thing out here? Well, unfortunately, we had a failed denial of service attack. Oh, address already in use. I mean, the address is already in use. Oh, I know what the problem is. Well, that's not that one. We want this one. We need to close our socket after we connect. So we'll connect, make a request. We should be able to print something out to the screen, but I'm not able to get. Was it I wonder if it's HTTPS. No, it's not. Let's just ask for slash. I need to move my input stream up top. I think, oh wait a minute. I think we need to read from the socket before we could write to it. Opens up on port 80, set up our scanner, read something from the scanner and print it out to the screen. It doesn't appear to be the case. All right, well this is fine because we need, this segues us to where we need to go anyways. We need to go look at the HTTP 1.1 protocol. Because right now we're speaking our fake language that we made up, that's HTTP-like. But there is a standard protocol see, is this going to give us any examples? Let me try that from the command line. Okay, that's better. Go back to my code here. I wasn't speaking the whole language. So we're actually going to open up a connection to this. No. Same connection, but our GET request is going to be a fully qualified URL saying we're speaking the HTTP protocol. And I hope this then gives us that response. So after we flush the output, we'll print out our HTML, which we saw just got spit back here. That's what that home page looks like. I'm going to double flush. All right, who cares? I don't know why our program's not working. We're just not talking to the Apache server very well because we're not using the correct HTTP protocol. We probably need to use one of the wrapper classes in Java to create a correct URI object, but it doesn't matter for right now. We see kind of how this stuff works. All right. So that's what a denial of service attack ultimately would do. It would just ping an IP address over and over and over and over again. So now if a server, like a web server, was sitting there and was just running on a while loop like this with a single thread, it could easily get bogged down. So what modern day web servers do is they multi-thread their servers so that each individual thread is able to hold up to so many requests. Now, one thing we can do if we want to kind of write this as a, it's like, oh, we just learned about threads, and now we're going to write this as a multi-threading thing and handle a request deal. I'm going to go ahead to our server. That's the client, so I'm actually going to close the client here so we don't get confused. So we're going to work inside the server, and I'm going to create another class in the server. And we're going to call this guy a response thread. And response thread is going to extend thread. And we're definitely going to have a public void run method in here, and we'll fill that out here in a second. But every response thread is going to have a private socket S associated with it. So let's import java.net. And then we'll have our public constructor. Where we set that socket up. Now, in our run method, so this is the thread that will get spawned off to deal with each individual request coming in. So what we'll do is we'll take all the stuff after we've connected. Take all this code down here, actually, just so we get it all. Let me take these 3 lines here. Get rid of those. We're going to put them in our response as private variables. Then I'm going to get all the rest of that stuff. We'll paste it into the run method. So in the run method, we're not going to be getting the input stream from something called connection. Instead, we're going to get the input stream from our this.s. That is the socket associated with this thread. We'll read our requests, split the parts, get the output stream from this.s, right back out to the screen. Oh, that's right, we had our all right, so we'll try to do all that crap, catch the error, and do nothing when there's an error. Because these 2 guys potentially threw exceptions. And we'll handle this individual web browser's request. So all we did is we took all of our code that we had in that infinite loop, that while true loop, and we put it inside of this class that extends thread. And most of it is inside this method called run. Now what we do is in our server, when we get a connection, what we do is we say new response thread passing it the connection, and telling that guy to start. So that takes that spawns off that thread, and now we're off to the races. Okay? Now threads are non-blocking, which means that while this guy is, remember we did this last time? As long as we had somebody, we were writing numbers out to one person, the other people couldn't connect. Weren't you number 3 out of 2 people?
No, it's 3 out of 40 people.
3 out of 40.
4 out of, yeah, because 0, 1, 2, 3.
Yeah. All right, so in any case, and I know we're out of time here, but now what it's going to do is if we did that same exact example now, everybody would be able to get their responses because this is not going to block. So the while loop would be able to come back around and keep working. Okay? So we'll pick up from there on Friday. We'll finish up this little piece, and then you will have an assignment over the weekend to write a fully functional web server that supports PHP, JSP. No, you will have an assignment over the weekend, but it won't be that bad. All right, I'll see everybody on Friday.